Hello, welcome to the seminar covering the topic of climate emergency, carbon monitoring, and carbon reduction. The content of the seminar is as follows: the introduction of the subject and the reasons for focusing on climate emergency, including greenhouse effect and greenhouse emissions, followed by discussion on global impact of climate emergency. The next section will focus on definition of carbon emissions in built environment with a focus on embodied and operational. The final section will cover the concept of circular economy. The history of built environment is about as long as the history of humanity itself, and probably just as complex. The exact origin of built environment could be said to date to the Neolithic period, around 10,000 BC, or simply when people stopped living in caves and started handling the way they want their houses to look and feel like. The buildings that we are talking about today are commonly assessed through visual terms and subject to ocular perception. But this urge to design an architectural outstanding jewel was fueled by much more than the mere need for aesthetic appeal. Built environment has proven to be many things: comfortable, elegant, modern, and yet one of its most interesting aspects is its capacity to reflect the spirit of time in a way that might be even more substantial than how we see it happen with art. The parallelism of history of architecture to human history is justified by its strong material presence that serves as the best physical evidence of societal change. Just looking at the buildings made in different places at a different moment in time would help us understand the evolution of architecture and our past without using any words. Human actions were embodied in architecture and further clarified through the persistent pursuit to protect some of the built heritage and to decide to let the rest of it fade and decay. Examples shown on the slide. On the left-hand side, Stonehenge as an example of a prehistoric structure, and on the right-hand side is Marina Bay Sands building in Singapore. The evolution of the built environment, together with technological revolution, have been occurring for the centuries. For centuries, as we were developing our civilization, we had no understanding how our activities affect our planet Earth. In the past century, our knowledge in this area significantly improved. Let's consider what makes our planet Earth special and what enabled development here. The greenhouse effect is the way in which heat is trapped close to Earth's surface by greenhouse gases. These heat-trapping gases can be thought of as a blanket wrapped around air, keeping the planet toastier than it would be without them. Greenhouse gases include carbon dioxide, methane, nitrous oxides, and water vapor. Scientists have determined that carbon dioxide's warming effect helps stabilize Earth's atmosphere. Remove carbon dioxide, and the terrestrial greenhouse effect would collapse. Without carbon dioxide, Earth's surface would be some 33 degrees Celsius cooler. Greenhouse gases occur naturally and are part of our atmosphere's makeup. For that reason, Its conditions are not too hot and not too cold, but just right to allow life, including us, to flourish. Part of what makes Earth so amenable is its natural greenhouse effect, which keeps the planet at a friendly 15 degrees Celsius on average. The exchange of incoming and outgoing radiation that warms the Earth is often referred to as the greenhouse effect because an agricultural greenhouse works in much the same way. But in the last century or so, humans have been interfering with the planet's energy balance, mainly through the burning of fossil fuels that add carbon dioxide to the air. The level of carbon dioxide in Earth's atmosphere has been rising consistently for decades and traps extra heat near Earth's surface, causing temperatures to rise, referred to as global warming. The gases in the atmosphere that absorb radiation are known as greenhouse gases, abbreviated as GHG, because they are largely responsible for the greenhouse effect. The greenhouse effect, in turn, is one of the leading causes of global warming. The most significant greenhouse gases are water vapor, carbon dioxide, methane, and nitrous oxide. Fluorinated gases are created during industrial processes and are also considered greenhouse gases. Although they are present in the atmosphere in very small concentrations, they trap heat very effectively, making them high global warming potential, abbreviated as GWP gases. Chlorofluorocarbons, CFCs, once used as refrigerants and aerosol propellants until they were banned by international agreement, are also greenhouse gases. There are three factors that affect the degree to which a greenhouse gas will influence global warming. Its abundance in the atmosphere, how long it stays in the atmosphere, and its global warming potential. For example, water vapor is the most abundant greenhouse gas, but carbon dioxide has a more significant impact on global warming due to its abundance in the atmosphere, plus its relatively long atmospheric lifetime of 300 to 1000 years. Water vapor, on the other hand, has an atmospheric lifetime of no more than 10 days, according to a 2020 study published in the Journal of the Atmospheric Sciences. Methane is about 21 times more efficient at absorbing radiation than carbon dioxide, giving it a higher global warming rating, even though it stays in the atmosphere for only about 12 years. Although methane and other GHGs are capable of trapping more heat than carbon dioxide, scientists still consider carbon dioxide to be the dominant greenhouse gas because its warming effect outlives the others' effects by centuries. As a result, emissions are measured in carbon equivalent. Some greenhouse gases, such as methane, are produced through agricultural processes, in the form of livestock manure, for example. Others, like carbon dioxide, largely result from natural processes like respiration and from the burning of fossil fuels like coal, oil, and gas. Other primary source of carbon dioxide is deforestation. When trees are felled to produce goods or heat, they release the carbon that is normally stored for photosynthesis. This process releases up to 4.8 billion metric tons of carbon into the atmosphere every year. Worldwide, the output of greenhouse gases is a source of grave concern. Over the past 60 years, atmospheric CO2 has increased at an annual rate that's 100 times faster than previous natural increases. The last time global atmospheric carbon dioxide amounts were this high was 3 million years ago, when temperatures were up to 5.4 degrees Fahrenheit or 3 degrees Celsius higher than during the pre-industrial era. As a result of modern-day CO2-induced global warming, 216 year was the warmest year on record, with 2019 and 2020 ranking as the next warmest, respectively. In fact, the 6 hottest years on record have all occurred since 2015. The warming we observed affects atmospheric circulation, which impacts rainfall patterns globally, said Joseph Byrne, an associate professor in the Department of Geology and Planetary Science at the University of Pittsburgh. This will lead to big environmental changes and challenges for people all across the globe. If current trends continue, scientists, government officials, and a growing number of citizens fear that the worst effects of global warming, such as extreme weather, rising sea levels, plant and animal extinctions, ocean acidification, major shifts in climate, and unprecedented social upheavals, will be inevitable. A climate emergency declaration, or declaring a climate emergency, is an action taken by governments and scientists to acknowledge humanity is in a climate emergency. The first such declaration was made by a local government in December 2016. Since then, over 2,100 local governments in 39 countries have made climate emergency declarations. UK has declared climate emergency in 2019. Populations that have declared a climate emergency amount to over 1 billion citizens. Parts of the construction industry are already taking a lead in addressing the challenge. Globally, the World Green Building Council has issued a net zero carbon buildings commitment, which challenges companies, cities, states, and regions to reach net zero operating emissions in their portfolios by 2030, and advocates for all buildings in operation to be net zero in operation by 2050. A number of UK construction industry professionals have made climate and biodiversity emergency declarations. These include established institutions such as the Royal Institute of British Architects, as well as collectives from UK structural engineering and UK architect professions who have come together to make joint declarations. Contractors have not collectively declared climate emergency in the same way as architects and consultants, but many have made pledges of their own. The UK Green Building Council has also recently launched its climate commitment platform. The platform is intended to represent the building industry's response to climate change by mapping the climate commitments and carbon reduction targets of its members, which include a number of leading UK construction operators. It also provides a forum for clients, developers, and contractors alike to detail their carbon pledges in a clear and unified way. In order to limit climate change, the UK government is committed to achieving net zero carbon emissions by 2050. LETI, along with other organizations, believe that this is not sufficient. Global warming is predicted to be limited to 1.5 degrees Celsius only if dramatic changes are made. Figure shows the magnitude of the change needed to reach net zero carbon. Net zero carbon needs to be considered in the context of whole life carbon. Whole life carbon includes operational and embodied carbon, and these need to be understood and considered very differently. Embodied carbon, carbon dioxide, and other greenhouse gases associated with the following stages. 1. Product, extraction and processing of materials, energy and water consumption used by the factory or in constructing the product or building, and transport of materials and products related to those processes. 2. Construction, building the development. 3. Use, maintenance, replacement, and emissions associated with refrigerant leakage. 4. End of life, demolition, disassembly, waste processing, and disposal of any parts of product or building or any transportation relating to the above. A new building with net zero operational carbon does not burn fossil fuels and is 100% powered by renewable energy and achieves a level of energy performance in use in line with our national climate change targets. This means that an operational carbon balance is met. For some buildings, such as small-scale residential, 100% of the energy consumption can be met on site with roof-mounted PV panels. Taller buildings have a smaller proportion of roof area to floor area, therefore investment in additional renewable energy off-site might be required. Such investment into additional renewables is not considered an offset. As well as achieving the zero carbon balance at a building level, it is important that this balance is also achieved at a national level. To meet the UK's climate change targets, all buildings must achieve net zero operational carbon because the amount of renewables that the UK can produce. Operational carbon, carbon dioxide and other greenhouse gases associated with the in-use operation of the building. This includes the emissions associated with heating, hot water, cooling, ventilation, and lighting system, as well as cooking by equipment and lifts. Operational carbon is based on the flow of energy and needs to be generated through renewables. Constructing buildings uses energy as well as resources, and once a building has come to the end of its life, these resources are still potentially available for use. Thus, in addition to reducing embodied carbon, we must consider the resource as a store rather than a flow, and buildings should be thought as a material resource banks. The embodied carbon emissions need to be considered with national and regional carbon budgeting. This means the carbon emissions themselves need to be reduced, which is why embodied carbon targets are being set for the upfront embodied carbon emissions. In addition, the material resources used need to be kept in the circular economy. This means the building reuses materials and products from demolished buildings and is designed for disassembly so that materials and products within the building can be reused in future buildings. To sum up, whole life carbon includes both embodied and operational carbon, as defined previously. A circular economy is an industrial system that is restorative and regenerative by intention and design. A circular economy replaces the linear economy and its end-of-life concept with restoration and regeneration, shifts towards the use of renewable energy, eliminates the use of toxic chemicals, and aims for the elimination of waste through the design of materials, product, and system that can be repurposed and reused. The circular economy concept shown in the bottom part of figure illustrates an evolution of this current linear economy top part to the circular economy bottom part, which is achieved through the application of principles maintain, repair, reuse, remanufacture, and recycle, as well as leasing and servicing. A subsequent slides will show example of circular economy in the context of built environment. The Wat Pa Maha Shido Karo temple has found a way to bottle up nirvana literally. The temple, which sits in Thailand's Sisaket province, roughly 370 miles northeast of Bangkok, is made of more than 1 million recycled glass bottles. True to its nickname, Temple of Million Bottles, features glass bottles throughout the premises of the temple, including the crematorium, surrounding shelters, and yes, even the toilets. There is an estimated 1.5 million recycled bottles built into the temple, and as you might have guessed, they are committed to recycling more. After all, the more bottles they get, the more buildings they are able to construct on site. There are many more examples to follow. The sky and imagination is the limit. And whenever thinking about those ideas, we should be thinking about building less, building light, building wise, building low carbon, building for the future, and building together. To sum up, we are in climate emergency. Our planet has reached a tipping point, and we urgently need to reduce carbon emissions to protect our children's future. In the UK, the built environment is estimated to emit 49% of annual carbon, thus holding many of the opportunities for a sustainable future. Despite calls for action and empty declarations, construction industry has been adjusting slowly. Within Maze, we are now taking a lead, committing ourselves to bigger, bolder goals so that we, our clients and partners, are all part of creating a world where sustainable communities thrive. We recognize that a deep retrofit of existing building stock has a crucial role to play in the delivery of net zero carbon future. This session is aimed at providing an overview of approaches to reduce and monitor carbon emissions, with particular emphasis on sustainable net zero retrofit. Hierarchy of action is to build less, build more lightweight, wisely, low carbon, for the future, and collaboratively. Now, it is time to check the knowledge you've gained through quiz questions. Good luck. Question 1. What are the greenhouse gases? A. Water vapor. B. Carbon dioxide. C. Methane. D. Nitrous oxide. E. All of the above. What 3 factors affect the degree to which a greenhouse gas will influence global warming? A. Reaction with oxygen. B. Abundance in the atmosphere. C. How long it stays in the atmosphere. D. GWP, global warming potential. What GHGs were banned by international agreement? A. Nitrous oxides. B. Fluorinated gases. C. Chlorofluorocarbons. D. All of the above. What is the size of the population declaring climate emergency so far? A. 1,000. B. 1 million. C. 1 billion. D. 1 trillion. What year has the UK declared climate emergency? A. 2016. B. 2017. C. 2018. D. 2019. What year has the UK government committed to achieving net zero carbon emissions? A. 2025. B. 2030. C. 2040. D. 2050. The answers. Thank you for listening.